In this video, we'll be going over two of the hardest induction questions in IB mathematics. So for the first question, as you can see on the screen here, you're first asked to solve an inequality and then use induction to prove a certain formula. So for part A, it's a very simple process of solving this quadratic inequality. So we know that the critical values in which x squared minus 2x minus 3 equals to 0 will be given by x equals to 3 and x equals to -1. The graph will look something like this. As a result, we could determine that the solution to this inequality would be x is greater than 3 or x is smaller than or equals to -1. So you remember the solution, and then we're going to attempt part B. What we want to do is prove that 2n is greater than n squared minus 2 for n is greater or equal to 3. So for n equals to 3, we get that 2 cubed is greater than 9 minus 2 is 7. 8 is greater than 7, therefore it's true. As per most induction questions, we will now assume that 2n assume true for n equals to k. So in other words, 2k is greater than k squared minus 2. So we will now consider a case where n is k plus 1. So for our left-hand side, we have 2k plus 1. Let's put our right-hand side here. It's k plus 1 squared minus 2. 2k plus 1 could be rewritten into 2k times 2 because we know that 2k is greater than k squared minus 2 as we got above. So we know that 2k plus 1 is in fact greater than 2k squared minus 2, 2k squared minus 4. Now, in what scenario would this guy be greater than this guy? So the only when 2k squared minus 4 is greater than or equal to k plus 1 squared minus 2 will left-hand side be greater than right-hand side. So as a result, we could find the values of k such that this inequality is valid. So we k squared minus 4, we expand the other side. And then after rearranging the terms, we notice that this is exactly the inequality that we solved in part A. So by A, we know that the solution to this would be k is greater than 3 or k is smaller than -1. Now, because we are given that n is greater than or equal to 3, we know that this is automatically rejected and that k is greater than or equal to 3 for n is greater than or equal to 3. Therefore, we know that 2k plus 1 will always be greater than k plus 1 squared minus 2 for k is greater than or equal to 3, which shows that 2n and n squared minus 2 is true for k plus 1. Therefore, it's true for all n greater than 3. So as you can see, when we're dealing with mathematical induction with inequality signs, what we were going to do is to set up the left-hand side and the right-hand side and modify the left-hand side using previous solutions, and then show that the modified left-hand side is greater than the right-hand side, as we could see here. Now for our second question, this is even more difficult. There's 3 parts to this question, and for A part, we want to prove that ln side, which is this, is smaller than right-hand side, which is this. Now, how can we do that? So we will first kind of rationalize, or not exactly rationalize right-hand side. So we will multiply n plus 1, we multiply this to this. Now, as you can see, the value is not affected because we're multiplying the same thing in the denominator and the numerator. And the expansion of this gives that you're going to get this over root n plus 1 plus root n, which is 1 over root n plus 1 plus root n. We will then compare the left-hand side to the right-hand side because we know that root n plus 1 is actually greater than root n plus 1 plus n because root n plus 1 is greater than root n. So therefore, we could apply 1 over both sides, and we're going to get that this happens. Therefore, this is smaller than root n plus 1 minus root n. For our b part, we want to show that 1 over root 2 is smaller than 2 root 2 minus 2. So we could just apply by a. We apply n is actually just n is 1. So we get that 1 over 2 root 2 is smaller than root 2 minus 1. So we could rearrange that into this. So pretty straightforward. Now C part, it is again mathematical induction with an inequality like the first question. Let's write it out. Let's see. So question. So show that this 1 over root r all the way to n, I believe, is smaller than 2 root n minus 2 for n is greater equals to 2. So we could write this in a nicer way. So it's just basically this all the way to 1 over root n is less than this. So for n equals to 2, 1 over root 2, this is left hand side, and right hand side, which would be 2 root 2 minus 2. Left hand side is smaller than right hand side, as given in b part here. So we can assume that it's true for n is equals to k. So 1 over root 2 plus all the way to 1 over root n will be smaller than 2 root k minus 2. So now we will consider the case where consider n is k plus 1. Our left-hand side would be 1 over root 2 plus all the way to here. And the right-hand side would be 2 root k plus 1 minus 2. Now, if you remember, the main approach to solving induction problems with an inequality in it is to modify the left-hand side and then solve another inequality. So we know that this portion is smaller than this. So as a result, we know that left-hand side is smaller than 2 root k minus 2 plus 1 over root k plus 1. Yeah. Now, so basically what happens is in order for left-hand side to be smaller than right-hand side, we need effectively that right-hand side is greater or equal to this section here. So we know that, so our new problem now becomes show that 2 root k minus 2 plus 1 over root k plus 1 is smaller than 2 root k plus 1 minus 2. Now in A part, we showed that, by A part, we show that 1 over 2 root n plus 1 is smaller than root n plus 1 minus root n. Now let's see if we copy that down correctly. Yep. So we will just say let n be k. See if we got the fact right. So after rearranging this, we get this. minus root n. So we will let n equals to k. Therefore, 1 over root k plus 1 is smaller than 2 root k plus 1 minus root k. So we need to modify this into this form, right? So we will begin by putting our root k to this side, and then alright, forgot the 2 here, my bad, forgot the 2. So we get this form, and then we just minus 2 on both sides. So this. So as a result, we show that right-hand side, which is 2k plus 1, 2 root k plus 1 minus 2, is greater than 2 root k plus 1 over root k plus 1 minus 2, which in turn is greater than the left-hand side, which is a really, really long term. So let's just write it this form, all the way to k plus 1. Therefore, our conclusion is that right-hand side is greater than left-hand side for k plus 1. Therefore, right-hand side is greater than left-hand side for all n is greater or equals to 2. And that concludes today's video, where we covered 2 of the harder mathematical induction questions that involves inequalities.